Let's dive into the different sampling methods. The best possible sample would be the entire population of interest. In order to get the most accurate picture of the US population, the government does the census every few years. In the illustration, you can see the target population, which is the entire group that we're interested in. Then we have the sampling frame, which may or may not be the exact target population, but there should be some overlap. And then we choose a sample. Again, the idea is to choose a representative sample. When we look at the census, what are some of the drawbacks? And the first one would be that it is very time consuming and it costs a lot of money. Now, the US government has a lot of resources, so they're able to do that. But oftentimes when we do research, we just don't have those funds available, which is why we choose a smaller group or different sample in order to collect our data. Other problems over here could be that we actually don't get everyone within our population. The government tries very hard to get a response from every person, but there is a missing population. First of all, they will send out the surveys. Then at some point they will come knocking on your door. But at some point, if they don't get a response, then you're going to have a certain population left out. So for example, our homeless population that's not registered anywhere, and we call this undercoverage. The problem oftentimes when we have a missing population is that these people may feel very differently than other people in the population. A last problem could be that there's sensitive data, which could lead to response bias. So there was a lot of discussion about illegal aliens in our country, should they respond to the census or not. So we have several different sampling techniques. We start again with our sampling frame, which is the list where we choose our sample from. The first, which is the gold standard of sampling, is our simple random sample, often abbreviated by SRS. Each member of the population and every sample of size n has an equal likely chance of being selected for the sample. This really equates to having a random number generator, choosing people from a list. Or it could be just, having each person in the population or each thing be on a little strip of paper in a hat, and we just randomly select. With that, we can choose anyone in our sample. Any combination of people could be in our sample. So it's a simple random sample, completely randomized. Then we have a stratified random sample. So again, it's random, meaning that each person has the same chance of being chosen. However, it's not completely randomized. So in a stratified sample, we're dividing our population into similar groups called strata. So for example, we could divide male versus female. Then we randomly select some of the males and we randomly select some of the females. This ensures that we may have the same number of males and females in the group. Or maybe if there's, more of one group, we can adjust our sample to have that same percentage. Another example would be when we're looking at classes within a school, we could have freshmen, we could have sophomores, juniors, and seniors. And then again, we randomly select some from each group. The idea is that the people within each strata are very similar in a way. So we call that homogeneous groups. Then next sampling technique is the cluster sample, and oftentimes stratified sample and cluster sample are confused. So it's very important to understand the difference between the two. In a cluster sample, our population is divided into groups called clusters. So this time they're heterogeneous groups, which means they are a good mix of the population. So oftentimes this is by geographic location. So again, we divide our population into different groups. Maybe we divide it by zip codes, and then we randomly choose some of those clusters, and we're gonna survey everyone within the group. So this time we're not picking individuals, but we're actually picking whole groups. So the difference over here is, again, for a stratified sample, we divide them into similar groups, and then we do a random sample from each one of the groups. With a cluster sample, we have mixed up groups. We randomly select some of the groups, and then we're selecting all or everyone. So those are some of the keywords for, cluster samples. So look out for those keywords. And the idea is over here, if each one of the clusters is a good mix, then the whole sample should be representative of the population. Oftentimes with a cluster sample, we have a lot more different groups because we're randomly selecting some of the groups, where with a stratified sample, we could have 2 or more stratas, but generally we're not going to have 100 different groups. The next one, which is a little easier to understand, is a systematic random sample. This is a random sample with a system. We are randomly selecting a starting point, and then we are going to select every kth person. So maybe every 10th person, every 15th person, every 20th person, depending on how big our population is and how many people we want to collect in our sample. So there is a system to it. We have a random starting point, and then we're going to select every kth person from a list. Now, all 3 of these sampling techniques are random samples, which means that every person has the same chance of being picked. Actually, all 4 of these sampling techniques, including the simple random sample. So these are all very, very good sampling techniques. Down here is an illustration just to, again, compare stratified sampling versus cluster sampling. Stratified sampling, we first split our group into these different stratas, and then we do a random sample from each group. Again, this could be 2 or more stratas. Cluster sampling, we divide it into heterogeneous groups, so these are mixed up group, and then we're randomly selecting some of those clusters. You can think of a grape cluster, and you simply go to your grapevine, you're going to pick some of those clusters, and then you're going to eat all of the grapes. So just think of that illustration. Now, all these sampling techniques are good sampling techniques, so they should result in a representative sample, as long as our sampling frame is very similar to our population. Now, if we're just choosing part of the population, then it could create some problems as well. On the next page, we have an example which we'll look at in class, but then we also have some poor sampling methods. Now, the idea with the poor sampling methods is, or their biased sampling method, because oftentimes they lead to very different results than our representative samples would, or they have very different results than our overall population. So one is the voluntary response sample, where individuals are asked to provide information and all who respond are counted. So this could be an internet poll. You're working on your computer, all of a sudden there's a poll and it asks you, how do you feel about the election? How do you feel about Social Security? Or maybe some other sensitive topic. And generally you will have people who feel very strongly about the subject. They're the ones that are going to be responding. So you may have 100,000 people respond to a survey, and yet you end up with very biased results. Another one is the convenience sample. This is where you select individuals that are easiest to reach. So if I want to do a survey about statistics, I may just go to my statistics class. Very easy, very quick, but you guys may feel very different than other students do. So again, a convenience sample tends to be a very biased sampling method.